Hi, my name is Violetta White, and I'll be doing the gummy bear burning lab. The reactants necessary for this lab would be gummy bears and potassium chloride. The materials needed for this experiment are a balance, tongs, funnel, tweezers, a Bunsen burner, a stand, and an ignition tool, as well as a vial made out of borosilicate glass. Warning: do not get potassium chloride in contact with your skin or eyes, and do not inhale or ingest it. Also, throw the tube away once reaction is complete and cooled. Please do reaction in fume hood and close the fume hood as soon as possible, and do not place hand near test tube while reaction furthers to completion. The grams of reactants necessary for this experiment are 6 grams of potassium chloride to 2 grams of sugar. But in one gummy bear, which I am going to be using, there is only 1.3 grams. So in accordance, I weighted 3.9 grams of potassium chloride to follow the ratio of 6:2 in the original procedure. But I only measured this amount to the second significant figure. Now, after you have found the weighted amount necessary and have weighted that amount of potassium chloride, now you need to place the vial into the stand and screw it in. Please tip the vial at a 45-degree angle so the gases emitted during the reaction does not affect the rest of it. Place the funnel above the vial and pour the potassium chloride solid into the vial through the funnel. Now, if it gets stuck into the neck of the funnel, like so, then use tweezers or a glass prod nearby to small the clumps of potassium chloride so it can go into the bottom of the vial. Once the Bunsen burner has been placed inside the fume hood, please make sure the main gas valve is on in order to ensure that gas is actually going up to the valve inside of the fume hood. Now place a stand with the vial screwed into it into the fume hood, and place the vial, the bottom part of the vial, to the topmost part of where you believe the fire will be when the Bunsen burner will be lit. Once it has been assured that the main gas valve is on, please turn the valve on in the fume hood for the gas, and place your flame ignition tool onto the Bunsen burner and light it. Now, burning solid potassium chloride may take between 2 and 5 minutes. Moving the Bunsen burner into a better position with your hand by grabbing it by the base, or turning off the fan for the fume hood may speed the process. Once the potassium chloride is completely melted, use tongs to place the gummy bear and just drop it into the tube while making it remain at a 45-degree angle. Though timing is necessary, for if the liquid is too hot, the gummy bear will just jump out. During your experiment, when you are placing the gummy bear with tongs into solution, it may get stuck. Don't worry, don't freak out. Just use a glass prod in order to push it into the solution. Do not use any metal substance whatsoever to make contact with. If you heated the potassium chloride liquid hot enough, but not too hot to spit the gummy bear out, the gummy bear will bounce from the solution to the midway of the tube over and over again while completing the reaction. If the potassium chloride had just melted completely into a liquid state when you place the gummy bear in, the gummy bear will actually stay at the bottom of the vial where the potassium chloride liquid is and produce the reaction from there out. As seen, the reaction time varies by how hot you make the potassium chloride, thus how long does the gummy bear actually stay in the vial. As reaction is going to completion, it is destroying the vial, as you can see, with the black substance coating the inside, and smoke will form out. Please wait until the reaction is completed and the substance is completely cooled, as well as the vials cooled, before attempting removal. Question time. What chemical concepts were demonstrated with this experiment? The answer would be chemical reactions and thermodynamics. The chemical reactions that occurred during the experiment were a decomposition reaction of the potassium chlorate into potassium chloride and oxygen, and a combustion reaction with the sugar and the oxygen produced by the decomposition reaction igniting into carbon dioxide and water. Signs showing that the decomposition reaction as well as the combustion reaction were occurring were listed below the equations. For the decomposition reaction, we know it was occurring because solid black stuff was formed, which was assumed to be potassium chloride burning. Oxygen was ignited in order to produce the burning light of potassium, which is purple. Also, we know the combustion reaction was occurring because the oxygen required for this reaction to occur was produced from the decomposition reaction, and the smoke emitted was vaporized H2O. The concept of thermodynamics is displayed for when this is an exothermic reaction, meaning it releases heat. Now, in enthalpy, we are wondering how much heat is released. We would like to calculate the heat evolved by the reaction. Now, after calculating the enthalpy of the reaction, which is multiplying the individual enthalpies of each substance by their moles, or of the miniature reactions, and you would receive negative 2,807.98. And this is good because it's negative, and negative enthalpy is necessary for an exothermic reaction. And in order to find the energy evolved by this reaction with this enthalpy, I took the grams of glucose I had in this reaction, which was 1.3, and then I converted it into moles by using the molar mass of glucose. And the moles of glucose I had from 1.3 grams was 4.0 times 10 to the negative third, or 0.004 moles. And I took those moles and converted it into the moles of reaction, and then the enthalpy of the reaction in order to find the energy created from what I had, which was 11.231 kilojoules. And thank you, Jillian, for being my lab assistant and helping me record this.